Hello friends, now we are going to do the numerical number 3 or the problem number 3 based on pH and pOH. So let us do the third numerical and which is quite different from the previous two. So let us do it. So therefore these are the data that are been given in the question. So let us extract the data first and let us talk about that how can we extract that. So talking about the concentration, so in that case the concentration that is been given is, so therefore we write it over here as given data. And given data, the concentration for the solution is been given as that is 0.02 molar. While that of the pH is also been given for the weak base, and in this case the pH is been given as that is 11.2. And we have to calculate the degree of dissociation of a monoacidic weak base. So since the pH has been given to us and that is basically 11.2, and since we are talking about a weak base, I would write it over here as. So now it is very easy for us to calculate what will be the pOH. So therefore the relation that we know, that is pH plus pOH is equals to 14. So in this case we will get to know that is what is basically the value of pOH, and that's the reason that 14 minus pH will be the thing. But why we are calculating pOH? Because the pH is already given to us. The main thing is because they have given us a weak base. They are talking about weak base, and unless we know that what would be the concentration of that is OH minus ions that are been present in the solution, so how can we able to calculate the degree of dissociation of the weak base? So that is the reason that we are calculating the pOH, and pOH is very necessary for that because pOH is related to that is a basic solution. So that is the reason now we are going to substitute over here. So therefore this is the 14 that we have minus pH that is 11.2. So in this case if we calculate the thing, then we'll get to know that is the answer would be basically 2.8. So the pOH is basically 2.8. So that is what we have, and so now in this case we have got the value of pOH, and now it would be very much easy for us to calculate what would be the concentration of OH minus ions. So let us do that also. So because we know that as pOH is nothing but it is the negative log of to the base 10 of the concentration of OH minus ions. So in this case we know the value of pOH, and that is been found to be that is 2.8. So now minus log of this one, that is OH minus. So how can we calculate this one? So what we have to do is we have to we can shift this minus on this side, so therefore we could write it over here as this one, that is log of OH minus, concentration of OH minus is equals to minus 2.8. But if this log will move over there, so therefore that would be turned into an anti-log. So therefore the OH minus ion, it would be nothing but minus or we could say as anti-log of that is 2.8. So let us calculate this thing and let us see what is the answer that we could get. So we have got a value of that is 1.58 into 10 raised to minus 3. So this is the concentration of OH minus ion that we have got in basically the solution that we have, that is that is containing 0.02 molar of the monoacidic base, and this is what we have got. But we have also a relation between the concentration and the dissociation constant. So that is basically, I will write it over here, that is the relation between the concentration of OH minus ion and that of the dissociation constant is basically alpha into C, and this C, it means that is the concentration of the solution, and because of which only some kind of dissociation will happen for the weak base, and that is the reason that is this much part of the weak base will be dissociated, and that would result in that is the OH minus ion concentration. And so that is what we have. But we have also the concentration of the overall solution, that is 0.02 molar, and that is 0.02 molar. So we're going to substitute over here, and that is, I write it over here as 0.02 molar. By that of the OH minus ion concentration, it was found to be that is 1.58 into 10 raised to minus 3. So now let us calculate what would be the alpha, or what would be the dissociation constant. So therefore it would be nothing but that is 1.58 into 10 raised to minus 3 divided by 0.02. So now let us calculate and let us see what is the answer that we could get. So we have got an answer of that is 0.079. So this is the degree of dissociation that we have got over here, and this is what I will have kept in square box. Oh sorry, a rectangle box. So thank you friends for watching this video. I hope you have understood this video and you have got to know that how can we calculate the degree of dissociation. So share this video with the friends, and yes, don't forget to subscribe to Ekeeda channel. Thank you so much.